In this video, we will discuss this solution found in the textbook by John Bird, Understanding Engineering Mathematics. This is in the practice exercises 259, number 9, on page 714. So the exercise or the problem is presented in this way. In electrostatics, we have this integral, and what we have to do is we have to show that this integral of the electric field is equal to a squared multiplied by sigma divided by epsilon multiplied by x. So we have to show that E is equal to this over here. We have to prove this. And of course, we have to prove this by evaluating the integral. So we have to evaluate this integral. All right, so let's go ahead and do that. But before we start, let's note something. If you look over here under the square root sign, in the textbook, this sign is negative. That is a mistake. It should be positive. So the sign, this sign here should be positive. It's the square root of a squared plus x squared minus 2ax multiplied by cos theta. That's what it should be. So the sign should be plus, not negative. So please make that correction before you proceed with the solution. Okay, so let's go ahead and solve this. Okay, now we are going to solve this using the algebraic substitution method. Okay, using the algebraic substitution method. So over here, we basically let u be equal to what's under the square root sign. So we let u be equal to a squared plus x squared minus 2ax multiplied by cos theta. Okay, so u is equal to that. Now we go ahead and differentiate u with respect to theta, and we're going to write our integral here of e. We're going to write it in terms of u. All right, so first, before we do that, we have to differentiate u with respect to theta. Okay, now another thing we have to note, a squared, sigma, epsilon, as well as x are all constants in this integral. So in this integral, a squared, sigma, epsilon, and x are all constants in this integral. So when you're differentiating u with respect to theta, a squared, or the derivative of a squared is equal to 0. So that's going to be 0, plus the derivative of x squared with respect to theta is also 0. And then we have minus 2ax, okay, multiplied by the derivative of cos theta with respect to theta, and that's going to be minus sine theta. So by differentiating u with respect to theta, we have to differentiate each and every single term of this expression here. And when we do so, this is what we get. We get minus 2ax multiplied by minus sine theta. And that is equal to the following. So when you multiply these two, you get a positive 2ax multiplied by sine theta. That's what you get over here. So that's what it's equal to. So now let us write, because we're going to substitute d theta there in the integral. So let us write d theta in terms of du. So we're going to cross multiply, and by cross multiplying, we're going to get that du divided by 2ax sine theta is equal to d theta. Okay, so we divide both sides by 2ax sine theta, and we get, and of course we multiply both sides by d theta. So we basically cross multiply, and we get that du divided by 2ax sine theta is equal to d theta. Du divided by 2ax sine theta is equal to d theta. That is what we get. Okay, so now let's go back to our integral here, because we want to go ahead and substitute into the integral. So we will do that. So we say the following. We say, therefore, our integral, of course, is a definite integral. Okay, we're integrating from 0 to pi, but first we are going to find the indefinite integral of this function. And then after we find the indefinite integral, after we solve that indefinite integral, we are going to then apply the limits of integration to our result. So we're starting with the indefinite integral. So the indefinite integral of a squared sigma multiplied by sine theta with respect, over 2 epsilon multiplied by the square root of a squared plus x squared minus 2ax cos theta d theta. So this over here is equal to the following. Now we've made the substitution. Okay, we've made the substitution, so we can go ahead and substitute. But before we do that, we can take out the constants. We can take out the a squared, take out the sigma because it is a constant with respect to theta, and then we divide this by 2 epsilon. So we take out the constant, basically the constant in the integral, and that's a squared multiplied by sigma divided by 2 epsilon. We multiply this by the integral of the following, of sine theta divided by the square root of a squared plus x squared minus 2ax multiplied by cos theta. So we haven't substituted yet. We haven't made the substitution yet. Even though we've done the substitution, we've done it, but we haven't substituted into the integral yet. So now we're here. So the next step is going to be us substituting into the integral based on our substitution that we did. Okay, so now we're going to substitute it into the integral. So now, okay, so this is equal to a squared multiplied by sigma divided by 2 epsilon. So now we go ahead and we do the substitution. Okay, so this is equal to this over here on the outside of the integral multiplied by the integral. So now we do the substitution. So we leave the sine theta as it is, and then at the bottom here we're going to put the square root of u, because we said u is equal to what's under the square root. So in place of what's under the square root, we're going to put u. All right, and then we showed that d theta is actually equal to du over 2ax times sine theta. So we replace d theta with that. We replace d theta with du divided by 2ax multiplied by sine theta. So we make that substitution. We make that substitution. So now, as we can see that on top here we have a sine theta. At the bottom we have a sine theta. So therefore, these sine thetas, they cancel out. Okay, so we go ahead and we cancel these out. Okay, so this sine theta and this sine theta cancel out, and we are left with what we have left with here. Okay, so we are left with the following then. So this is now equal to a squared sigma over 2 epsilon multiplied by the integral. Now, another thing we note that at the bottom here we've got 2ax, which is a constant. So we're going to take it outside of the integral. So we can take that outside the integral. So that's going to give us the following. Now we have 1 over 2ax. Okay, so we've taken the 1 over 2ax outside of the integral. And now inside the integral, we have the following left. We have 1 over the square root of u with respect to u. So that's what we have now. Now, we can simplify this. We can write this as follows. Okay, so we've got a squared. Okay, but then before we do that, we note that the a squared over here and the a over here, they cancel out. Okay, so when they cancel out, we are left with a at the top, and there are no a's at the bottom. So let's go ahead and do that. Okay, let me say that again. I'm going to say that again. We cancel out, or the a squared and the a cancel out. So at the top, we are left with 1a. At the bottom, we are left with no a's at the bottom. So now at the top, we've got a. Okay, so it's a multiplied by theta at the top. And then at the bottom, we've got 2 times 2, which is 4. So that's 4. 2 times 2 is 4. And then we have epsilon. And then, of course, we have x. Okay, so we've got a theta divided by 4 epsilon x at the bottom. Okay, I think I made a mistake somewhere. Okay, let me fix the mistake I made. I see where I made a mistake. Where I made a mistake is over here. So let's fix that. This is sigma. It's not theta. I think the way I wrote it, maybe this is the way I wrote it. This should be sigma. So over here we have sigma. This is sigma, not theta. Sigma. Okay. All right. So we have a multiplied by sigma, right, over 4 multiplied by epsilon multiplied by x. So that's what we have outside of the integral. And then we multiply this by the integral of, okay, let's rewrite this as follows. So we can write this 1 over square root u, we can write it as u to the power of minus half. We can write it like this. So we're integrating this with respect to u. So we go ahead and perform the integral. Obviously, we're going to use the power rule. Okay, over here, we are going to use the power rule of integrals. Okay, so this is equal to a multiplied by sigma divided by 4 multiplied by epsilon multiplied by x. So we apply the power rule of integrals, which states that this integral is equal to u to the minus half plus 1 divided by minus half plus 1. Okay, all right, so that's what we get. And we are not going to put a plus c here because we're doing this just to get the antiderivative. Okay, what we are evaluating really is a definite integral. We're just doing this to get the antiderivative. And then after we get it, we're going to apply the limits of integration. So let's go ahead and do this. So this is now equal to the following. So we're going to have a multiplied by sigma here, multiplied by, or let's put this at the bottom. We have 4 multiplied by epsilon multiplied by x multiplied by the following. So we're going to have u to the half multiplied by half. Okay, so it's u to the half, u to the 1 minus half, which is a half, divided by a half. Okay, and that is equal to the following. Let's see. So we can rewrite this as follows. We can write it as a multiplied by sigma multiplied by 2 multiplied by the square root of u. So we can write it like this. And then at the bottom, we've got 4 multiplied by epsilon multiplied by x. So we can write it like this. And then now what we're going to have is the following. Okay, the 4 and the 2 obviously are going to cancel out. But then at the top, there's no 2's anymore. We just have an a sigma multiplied by the square root of u. Okay, and then at the bottom, there's a 2 multiplied by epsilon multiplied by x. So now this is what we have at the bottom, you see. So this is basically our antiderivative now. This is our solution to our indefinite integral. Okay, but since the indefinite integral was in terms of theta, we have to leave our answer in terms of theta as well. Okay, so the u we're going to replace the u with what we said it is originally. So this is equal to now a sigma multiply, we can say a sigma over 2 multiplied by epsilon multiplied by x multiplied by the square root. Now we replace the u with what we said it is in the substitution. We said that u is equal to this. Okay, a squared plus x squared minus 2x cos theta. So now we go ahead and we replace u with that in the answer. Okay, so we go back to the answer and we replace u with that. So we put here a squared plus x squared minus 2ax multiplied by cos theta. We do this. Isn't that so? So now we're here. Okay, so now we have our antiderivative. So now what we want to do is we want to now apply the limits of integration to this antiderivative. So we say the following. We say, therefore, the integral, which is now e, we can say, therefore, we can write e over there. We can say, therefore, we can say e is then equal to, okay, well, it's equal to the integral from 0 to pi, right? We know that e is equal to the integral from 0 to pi of a squared multiplied by sigma multiplied by sine theta divided by 2 multiplied by epsilon multiplied by the square root of a squared minus, not minus, not minus, please, it's plus x squared. The textbook says minus, but it's actually plus. So it's the square root of a squared plus x squared minus 2ax multiplied by cos theta. Okay. Yes, that's correct. And we do this with respect to theta. So now we go ahead. This is equal to the following. So now we have the antiderivative of this. So now what we have to do is just take the antiderivative and apply this limits to the antiderivative. So our antiderivative is our result from our indefinite integral, which is a times sigma over 2 epsilon x multiplied by the square root of a squared plus x squared minus 2ax multiplied by cos theta, right? Square root of that. And now we have to apply these limits of integration. We have to apply 0 and pi. Okay, so we go ahead and we apply that. So now this is equal to the following. This is equal to a sigma divided by 2 epsilon x multiplied by the square root of a squared plus x squared minus 2ax multiplied by cos of pi. Okay, so we first start with pi. We first start by applying or by substituting pi. We first start by substituting pi in there. Okay, so we go ahead and substitute pi in there. Close brackets like this, and we go minus. Okay, go minus with a sigma divided by 2 epsilon x multiplied by the square root of a squared plus x squared minus 2ax multiplied by cos of 0. Okay, so we first start by applying pi into the antiderivative, and then of course we apply 0 in this way. Okay, so this is how we evaluate this indefinite integral here. And then we go ahead and evaluate this. Now this is equal to the following, because we know that cos pi is minus 1. So this is going to be, so the first bracket is going to be a sigma divided by 2 epsilon x multiplied by the square root of course, a squared plus x squared minus 2ax. Let's correct that. As we said, cos pi is minus 1. So since cos pi is minus 1 times minus 2ax is positive. So over here in the first bracket, this should be a positive now. So we get that. Okay, we get that over there. And then the second bracket, what it gives us is the following. Go to the second bracket. We have a minus. Okay, let's put the minus here. Minus, and it's minus a sigma over 2 epsilon x. Okay, multiplied by the square root of the following. Now cos 0 is positive 1. Cos 0 is positive 1. So this is going to be a squared plus x squared minus 2ax. Because positive 1 times minus 2ax is minus 2ax. Okay, so that's the second bracket over there. Now, if we want to, we can take out the a sigma over 2 epsilon x as a common factor, because it is a common factor. So we can take it out. It's a sigma over 2 epsilon x. We can take that out as a common factor. And then inside the bracket, now we have the following. Now we've got the square root of a squared plus x squared plus 2ax. Okay, right? Minus the square root of a squared plus x squared minus 2ax, right? Close this, and then we close brackets over here. So now we're here. So now we can factorize this and write it as a, let me rewrite it. Okay, it's really the same thing. So what's under the square root sign here, we can factorize it and write it as x plus a squared. So when you expand x plus a squared, you get what's under the square root sign here. So these are equal. Okay, right? Again, if you factorize this over here under this square root sign, you get x minus a to the power of 2. You get this. Okay, so when you expand x minus a to the power of 2, it gives you this over here. Okay, so then we have that this is equal to a sigma over 2 epsilon x into the bracket over here. Now in the bracket now we have, so now we replace what's under the bracket, what's under the square root sign there, we replace it with x plus a squared minus the square root of x minus a squared. So we have this. So now we can see clearly that the 2 and the square root signs will cancel. So the 2 and the square root sign cancel. And now that means that we have the following now. Now we have a sigma over 2 epsilon x multiplied by the following. So inside the bracket now we have x plus a. We've got minus. Okay, I can write brackets first. I've got x plus a minus x minus a. Okay, close bracket. But then obviously this minus, if I distribute this minus into the second bracket, I'm going to get minus x and plus a. So this is going to give me the following. This is equal to a sigma divided by 2 epsilon x multiplied by x plus a minus x plus a. It gives me this. Okay, so obviously we can see that the a's will add and give us 2a, and the x's will cancel out. So these 2 x's will cancel out. So this is now equal to a multiplied by sigma over 2 epsilon x multiplied by 2a. Okay, so obviously the 2's will cancel, and we now have the following. We now have that this is equal to a squared, because the a's a sigma times a That's going to give us a squared multiplied by sigma over epsilon x, which proves the result, which proves that the integral for e is indeed equal to a squared sigma over epsilon x.